It's multiple pages. It is not the one we were working on the other day. I have finished that one with the other class, and it is video. We are now working on this. Okay, we're starting with number 1. Here we go. Might be. All right, so thinking about invertible functions, identify which of the 4 is the odd one out. So what that means is, which one doesn't fit with the rest of them, all right? In terms of being an invertible function, that's our framework. So think about that for a second. Which one? Anybody have an idea? Well, can you tell me what does y equals negative x to the 5th look like? You know what that looks like? Anybody knows what it looks like? Be careful. That's not an exponential. Why not? Why isn't that an exponential? Because x isn't the exponent. That's a 5th degree polynomial. What does x cubed look like? Airdrop for me. What does x cubed look like? Okay? That's what x to the 5th looks like. That's what x to the 7th looks like. So upside down, this is going to look something like this. That's the general shape of it. It's x cubed, x to the 5th, x to the 7th. Everybody good with that? All right. What does e to the x look like? Now that one is exponential. What does e to the x look like? Yep, that looks like that. That's e to the x. What does x to the 4th look like? Parabola. X to the 4th, x to the 6th, x to the 8th. And what does y equals 1 over x look like? That's a BFF. That is your reciprocal function. Looks like this. Now, every single one of these is a function. Would you agree with that? Because it passes the vertical line test. Do all of these pass the horizontal line test? All of them do except that one. That's the odd one out. And why is it the odd one out? Because its inverse is not a function. Remember, to have an inverse that's a function, you have to be 1-to-1. And 1-to-1 means you pass the vertical line test and the horizontal line test. All of these do that except for him. His inverse is not a function. Because there are repeated y's, which means when I do the inverse, I will have repeated x's. Okay, got it? All right, that's from a while ago. All right, number 2. We have 2 functions. P is the equation, G is the picture, and we want to find 2P of G of 0. All right, what are we going to do first? Find G of 0. And that's going to come from our picture. So it looks like G of 0 is -4. So this right here is -4. So now we're going to find P of -4. And we're going to do that carefully. P of -4 is going to be -4 squared plus 9. Is everybody okay with that? So -4 squared is 16. -16 plus 9. I got -7. Did you? But remember, I need to double it. So the answer to the problem is -14. good? You careless people are going to screw that up because of all those negative signs, so just be careful. Be good. All right, without finding the inverse, answer all these questions about the inverse. All right, so let's look at the original function. What can you tell me about this? Forget the inverse for a second. What can you tell me about this? What's its domain? Alex?
Negative infinity to 4 and 4 to infinity.
Exactly. Isn't it everything except 4, you guys? Isn't your domain? I'm talking now about the original problem. This is not the answer to the question. This is the original. The domain's everything but 4. All right, what about the range? Everything but 0. This will have a horizontal asymptote at 0. So it's everything except 0. Perfect. Wonderful. And I just answered one of my own questions. This will have a horizontal asymptote at 0 and a vertical asymptote at 4. Would you agree with that? So now if we have to answer questions about the inverse, it's easy, because what happens with an inverse? We just change our variables. So if this was the domain of the original, it will be the range of the inverse. So where you're finding the range of the inverse, this is it. And then this is the domain of the inverse. If this was a horizontal asymptote of the original, it will be a vertical asymptote, and this will be the horizontal asymptote. Now, remember, when you make this a vertical asymptote, you change that to x equals. And when you make this a horizontal asymptote, you change it to y equals.
If you don't mind me asking, what's like the practical use of us doing that? Finding all this stuff without doing the inversion?
Well, the idea is you're supposed to understand the relationship between the original and the inverse. So there really isn't any need. Okay, if I found the inverse, I would still have to use the same thought process to answer these questions. So this way, I just save the trouble of finding the inverse. But our goal is for you to understand the relationship between inverses. Okay? All right, fine, now we're finding an inverse. And, all right, so our function is this. So how do we find an inverse? Switch our x's and y's. And then solve for y. Now, before we move on, let's look at the original. What is the shape of the original? A parabola. Like this, up 4, like that. So its inverse is going to be this parabola. Does that make sense to everybody? Okay. Now, this must be the equation of that. It looks strange, but remember, we haven't spent a lot of time talking about this, but an x squared equation is a parabola opening up or down. A y squared equation is a parabola opening left or right, okay? So this is just the solved for y version of that right there. Now, what does this mean that in the original, x had to be less than or equal to 0. That means in the original, I was only allowed to look at that part of the parabola. But what does that mean for the inverse? I'm only going to be able to look at this part of it. So instead of technically, algebraically, that's plus or minus, I only want the negative piece because y has to be negative. What would be the value in doing that, the practical value in doing that? Was the original inverse a function? No, but if I do this, is that piece alone a function? Yeah.
Do we write it with a negative sign, or do we just write like y equals square root of x minus 4 when x is 3?
I would just write it like that, personally.
Okay.
And clearly now, x has to be bigger than or equal to 4. And now y will automatically come out negative.
Okay.
You don't need to write that because it's going to automatically come out.
Thank you.
All right. 2 statements are true, 1 is a lie. Find the lie. All right, see if you can figure that out with your friend. Question number 5. 2 of them are true, 1's a lie. Which one's a lie? Anybody have an idea? Have you figured it out yet? C is the false, the lie. Fred says C is the lie. Okay, so let's look at every statement first of all. What does x cubed plus 2 look like? X cubed plus 2 would be our squiggle through 2. When we say it's invertible, what we mean is its inverse is a function. Is the inverse of that a function? Yes, because it passes the horizontal line test. So the increasing invertible, true. Has a y-intercept at 0, 2, absolutely correct, which means its inverse will contain the point 2, 0, absolutely correct. So the issue is with the inverse, that last statement. So Kellen said that we shouldn't be cubing this, we should be cube rooting that, absolutely. Yeah. So C is correct, C is the lie, and then this would be the correction. Does that make sense to everybody? All right, let's look at number 6. Oh my. Circle the domain restrictions that represent invertible pieces of the non-invertible function P. So why is that picture non-invertible as a whole? Why is it non-invertible? Doesn't pass the horizontal line test, okay? So your job is to figure out, okay, they give you little intervals. Is the interval from negative infinity to negative 1.423, would that be a function? Or would that be allowed to be? Yes. So that first group works. What about from negative 1.423 to infinity? Nope. How, negative infinity to infinity? Nope. How about negative infinity to 0? Nope. How about the negative 1.4 to the positive 1.7?
Yeah.
Yeah? And then 1.7 to infinity? Yep. Everybody okay with that? Look very complicated, it's pretty easy. All right, how do we feel about decomposition? That's what we're doing here. We have a couple of functions, f and g, and when we put them together, that's what we ended up with. So now your job is to find an f function and a g function, individual functions, that when you build a composition, particularly that composition, you end up with that. More than one answer possible. So what is your gut saying? Anybody have an idea? Yes,
Can it just be f of x equals 2x, then g of x equals
this is 2x and this is
x squared minus
x squared minus 4. Well, that certainly is a legit guess. Let's see if it works. This composition says take g and plug it into f, right? So if I use these two functions and I plug g into f, I would get 2x squared minus 4. Would you agree with that? Does that give me what I'm supposed to be getting up here? No. So it's a good guess, great idea, but I check it, it doesn't seem to work. All right, so now we got a head start.
f of x equals 2x, and then g equals x minus 2.
X. That right there?
Yeah.
Okay, let's check that one. So that means take G and plug it into F, right? So that would be 2x minus 2. Declan?
Would you just do f of x equals 2x squared minus 4, and then g of x equals x?
No. No, can't use the identity.
Squared
Don't use the identity. Use two functions that aren't the identity. Okay.
F of x,
Okay, Mark.
could g of x be x squared minus 2 and f
Could,
of x is
could
just,
g of x be x squared minus 2, okay?
then just keep the other ones 2.
And what's that?
F x is 2.
Just 2. Alright, let's try that. We're building f of g of x. So we're gonna take this, oh, wait a second.
You need an x.
Mark, help.
F of x equals 2x.
F of
No, it
x
doesn't
is
work
gonna be
either.
2 no matter what, because there's no x to plug it into. So what'd you say, Alex?
F of x equals 2x.
Alright, now I can plug that in, so that would be 2x squared minus 2. Does that work?
Yeah.
Wow. You guys way overthought that, except for Declan who tried to do the end around. Guys, stop and think about it. This is fine. This is fine. There's multiple answers, and that would be fine. That would be 100% accurate. I want you to go back to the problem though. Tell me what's happening up here. There are 3 operations happening. We're taking a number and we're squaring it. We're timesing it by 2, and we're subtracting 4. So we need to build functions that do those 3 things. So think about this for a second. What if we let the first function, which is g, be the first things I need to have happen in my problem, which are squaring and timesing by 2. So what if I made g 2x squared? Then the only thing left for F to do is subtract 4. So how about that? Or, what if I let my first function simply square? That's the first thing that needs to happen in the order of operations up here. Then what would the second function have to do? Multiply by 2 and subtract 4? So my second function would be 2x minus 4. Now, all that work you guys did, again, you came up with an answer, and it's perfect. There are lots of answers you could come up with. But don't get bogged down. Think about what we need to do, and then build functions that do that.
Couldn't we have just done f of x is x, and then have g of x just be the whole thing?
Were you listening to me when I talked to Declan?
No.
No, we don't use the identity.
Oh.
That's kind of cheating.
Well,
It works, I get it, but no.
that
We're
wouldn't
not
count
using
on,
the
it wouldn't
identity.
count on the test.
If you did it on the test, I'm gonna mark it wrong, because we had a conversation, we're not using the identity.
There's a bad.
Grab the pass right there. All right, number 8, the key word here is prove. All right, prove. There is one way, and one way only, to actually prove that things are inverses. Does anybody remember what that is? Alex?
F of g of x equals 0 and g of f of x equals 0.
No, they don't equal 0.
Or they equal.
You chose it up?
No. I mean, ultimately they do, but what do they have to equal? Declan?
Wasn't it like f of x equals the opposite of?
No.
When you plug one into the other, it doesn't have to equal x.
Exactly. So f of g of x is x, and g of f of x equals x. So as Fred so eloquently put it, when you plug one into the other, you gotta get x. Because what's happening here is, I'm starting with x, I'm putting it into g and getting something, then I'm putting that into f, and if they're inverses, I have to go back to the beginning and get my x back again. So, you have to do both of those. Both of those have to be done. So, here we go. If I'm doing the top one, I'm going to do f of the square root of x plus 3 over 2. So that will be 2 times that squared minus 3. Is that okay for f of g? Does it work? If I square that, don't I just get x plus 3 over 2? And if I multiply by 2, that will cancel. And I think we got it. Okay. Now I'm gonna go the other way, so I'm gonna find g of f, which means the square root of 2x squared minus 3 plus 3 over 2. Won't that be 2x squared over 2? Does that work? So I just proved their inverses. That was a test question or a quiz question at another point in time. And I remember what some of you did was you took your original function f and you found the inverse of it, by switching the variables and doing the math, and said, oh look, I got g, so they must be inverses. That isn't the proof, all right? I get it, I understand it, but it's not the proof. The proof is right here. So if you have to prove next Tuesday, that's what I need to see, okay? All right. Number 9. multiple choice. What do you think? What'd you say? So, what is that, C? Fred says C. Raise your hand if you agree with Fred. I got one back there. Two.
Trust
Oh,
Fred.
now
I trust
we're
Fred.
getting a little braver.
Trust
Fred, they didn't trust you, but as soon as some of these others
No.
started raising their hands, they went along. No, he's exactly right. What happens to the three, you guys, the exponent?
Moves out front.
It moves out in front, becomes a multiplier, and what do multipliers do? They are vertical dilations, exactly, exactly. Good work. Without the regression feature, find the equation for this logarithmic set of data. So our format is a plus b ln x. So 12 equals a plus b ln 3. And 15.5 equals a plus b ln 10. Now I think I'm gonna need a calculator, but I'm not to do regression. So, here I go. What do you think I should do here?
Isolate it.
So, A would be 12 minus B ln 3. And A would also be 15.5 minus B ln 10. Is that all right with everybody? I subtracted this over to get A by itself, subtracted this over to get A by itself, and then set them equal to each other. Does that look okay? Now I'll start moving things around. So B ln 10 minus B ln 3 equals 3.5. I subtracted the 12 and added the B ln 10. Still with me? Now what?
After the B.
Factor out of B. You're trying to solve for B, so we'll factor it out. And so we have B ln 10 minus ln 3 equals 3.5. Yeah. One thing, it's perfectly okay. We could now divide by that, right? So 3.5 divided by ln 10 minus ln 3. But you could also rewrite this. How could that be rewritten? You wouldn't have to at all, but how could you rewrite that? ln 10 thirds. So it doesn't really help that much in this case, but in some problems that might make the problem more, easily done. So anyhow, what do we get here? Well, I just got an error. Oh, I see. So 3.5 divided by. Helen got what? Say it louder so we can hear.
2.907.
That's what I got. 2.907. So remember, that's B. So I've got 2.907 ln x. Now I have to figure out A. So I'll just come back here. Isn't this A right here? So 12 minus that thing. Times ln 3. Did you get 8.806? How's that look to everybody? Does that look about right? next one. You okay with this? Everybody good here? Alright. Now be very careful with the next one. At first glance, I thought, oh, this is gonna be an easy problem. But what? The bases aren't the same. So we can't drop the logarithms if the bases aren't the same. Oh my goodness. Okay, open for ideas. Alex,
Would you, make it log 9 and 3 squared? Like, would you make the 9 into 3 squared? And then do like I was saying earlier, where you do the fraction thing?
well, 9 is 3 squared. So you're gonna make this into a 3 squared.
Yeah.
Okay,
And
then they
can
still
you-
don't match, so then what are you gonna do now?
Wouldn't it be like 1/2 log 3 equal, 8x minus
Okay, okay, let's look at this for a second. Yes, good thinking there. I'm afraid we're gonna lose some people there. So let's maybe do something that's a little bit more obvious. Why was this problem harder than we thought? Because the bases didn't match. So remember, you can make the bases whatever you want. So this right here, that right there, I'm doing that one because it's the simpler of the two expressions. That right there is the log of x over the log of 3. And you need to know that, so change your base formula. Now, I have written here with a base of 10, but I could easily make those base 9. Right? So now this is the log base 9 of x divided by the log base 9 of 3. It's, in other words, it's a vertical relation. What is that? That's what Alex was talking about. What's the log base 9 of 3? That's evaluatable. What is that? 9 to what power is 3?
1/2.
So isn't this 1/2? So we have the log base 9 of x divided by 1/2. So this is 2 log base 9 of x. Because we divided by 1/2. Now what happens to that 2? It's an x comment. And now, can we do, oh, Sylvia?
It's a 15. not a
Oh,
5.
what's a 15? Oh,
Fraction.
thank you. Thank you. That might help things, actually. That will help things a lot. Good, thank you. So now we can drop them. So 8x minus 15 equals x squared. X squared minus 8x plus 15. That's gonna factor. And I'm getting 2 answers, are they both okay? Will 5 and 3 both be okay? Sophia?
I did it a different way, and I was just wondering if it works for like all equations.
I'm sure it probably
Like,
does.
I made the 9 into 3 squared, and the 3 squared equals 8x minus 15. And then I made the log, and then I made the base of 3 squared too, and then I squared the x, and I put them equal to each other.
So that's kind of what Alex was talking about. I just, let me think about that. Let me think about that. Because I'm trying to figure out a legitimate reason, I mean mathematically, what's the math behind squaring that and squaring that? I mean, I'm gonna try to figure that out, but I don't wanna do that right now, I'll do that at my own time. What I'd like everybody to at least consider is, the very first thing you said to me when we put this problem on the board, the bases don't match. And so, we have a legitimate method, a theorem, of how to change bases. So that's where I'm gonna start, there. Now, I'll go back and look at this other stuff and see if I can figure out what's going on. But I'd like you to at least think about that. Changing into the base you need. I don't have a base 9, I need a base 9, I can change it automatically. Alright, and all that's, you and Alex, Sophia and Alex have thoughts on that, I just need to process it, but not right now. I'll try to get this done. Number 12. Number 12. Find the inverse. You guys are really good at this. I think we may have done this yesterday. I did it with some class yesterday. How do we find the inverse of this thing? This is easier than most of the ones we've done. What do we do? Change our variables. Change my variables. Log base 4 both sides. So log base 4 of x equals 3y minus 8. Add 8. Divide by 3. And that will be your inverse. Alright, how about 13? 13 is more of an algebra problem. Let's do it anyway. How do we find the inverse? Well, we start the same way, so we'll start by switching the variables. Okay. Then what? We did some of these in our notes, I remember. What do we do now? So 2xy plus x equals 3y minus 8. Bring this over here.
Get the y's on one side.
So either side doesn't matter. So 2xy minus 3y equals negative x minus 8. So rearrange these two terms, in other words. Factor out the y. And divide. So our inverse will be negative x minus 8 over 2x minus 3. Everybody kind of remember that? Alright, then we got a section just like we had on the quiz we just took. Most of you did great. Some of you missed some of these. We don't want to miss any of these. 36 to the negative 1/2 is 1/6. Now you do as many steps as you need to on that. 1 over because of the negative, 6 because it's the square root. Perfect. ln1? 0. Any log of 1 is 0 because you have an x-intercept there. Okay, log of 1 over 100, negative 2, because 1 over 100 is 1 over 10 squared, 10 to the negative second, negative 2. Ooh, log base 4 of 8. Some of you are going to be able to do this in your head. If you can't, because 8 isn't like an integer power of 4, you can always do it this way and get 3/2. that all right with everybody? What about E? 4, 2 to the 4th. F, -2. Right? We're getting that? How about G? Not possible. Can't take the logarithm of a negative. Even though some of you tried on your quiz, can't take the logarithm of a negative. And how about H? 1/2. 7 is 49 to the 1/2. Very, very good. All right, let's do one more problem. Let's get A done. All right, what's your strategy gonna be with problem A?
Make the basis 3.
There's that common base thing again. You wanna make the bases the same. So 9 is 3 squared. And what's 1/27? 3 to the -3rd. Very, very good. No fractions. No fractional exponents. It's not a radical. All right, so 4x minus 6 equals -3x minus 12. Keep an eye on my arithmetic. 7x, I got -6/7. Anybody else get that?
No.
Now, do I need to worry about that at all? No, because this is not a logarithm problem. This is an exponent problem, and it's okay to be negative and an exponent. Let's do one more. I thought we were gonna run out of time, but that didn't take long. I promise. Last one. Here we go. I promise. Thoughts on this one?
Put the logs on the same side and equal to 1.
Put the logs on the same side equal to 1. So log base 7x plus 2 minus log base 7 2x equals 1, like that.
Yeah, make them pause.
Then we can combine these guys into a division.
Then
You do. So 14x equals x plus 2. Boy, I feel like I probably made a mistake somewhere. I got 2/13.
that's all I got.
Go back to the original problem. I think 2/13 would fit. Did anybody have any other thoughts? That is absolutely magnificent. Avery?
Would you make the 1 log 7 base 7?
Exactly. So if you wanted to, you could change that whole number into a logarithm. And then your equation would look like this. Am I gonna get exactly the same answer? Yeah. So that would be up to you. You could make that. Okay, so game plan, one more day of review. We'll do all homework questions on Monday. We'll do as much other review as we can. Between now and then, you might want to go through and see if there are specific things you want to make sure we hit. We still have part of one review sheet, part of this review sheet, and a whole other review sheet available to you.